Hey everyone, it's Justin again. Today we're going to learn how to graph exponential functions when given an equation, and we're going to use a table to help us out along the way. We're also going to talk about the similarities between an exponential function's equation, table, and graph, so we can always have lots of ways to check our work as we go. Before we get started, make sure to complete the warm-up on the cover sheet for this lesson. If you haven't done this yet, pause the video now and work through it on your own. Let's start with an equation that represents an exponential function. The goal of this lesson is to be able to make a graph of this, but before we do anything else, let's make predictions about what our graph is going to look like. So, by looking at this equation, what can you tell me about what the graph should look like? What do these numbers tell us that can be helpful when graphing this? There's some space in your guided notes to document your predictions. Pause the video now and take some time to fill that in. Just by looking at this equation, I could see the y-intercept is 3, and the growth rate is 2. Since this rate is greater than 1, we know that this represents growth rather than decay, and our graph will go up from left to right. That's a really great start. With just this information, I already know that the graph should go through this y-intercept of 3 and go up in this general direction. I also know it'll start off kind of flat and then go up more and more quickly, but just how quickly does it actually go up? We'll definitely need to get some points that we can plot to help make our graph more precise. That's why we need a table. We can evaluate this equation at these x values to help us get some exact points for the graph. If we use these values, we'll have enough points to see the general flow of the line, plus using a few points on either side of the y-intercept can help us see this line's behavior better and make our sketch more accurate. Let me try this here. Let's see. If x is -2, then I have 3 times 2 to the -2 power. I can make that exponent positive by moving this base of 2 down with it. And 2 squared is 4. Ooh, okay. I got 3/4, or 0.75 if you prefer the decimal form. Go ahead and fill in the rest of this table yourself. These calculations were in your warm-up, so take a moment to transfer your answers into this table. Pause the video now so you have time to do this. So, how did it go? Did you get the same values that I did? If not, stop for a moment and check your work. It's important to take care of little calculation errors now so you don't continue to make the same mistakes later. Now that we have this table, let's stop to form some connections to what we know from earlier in the unit. This number, 3, is the a value of the exponential function, or our y-intercept. Do you see that on the table? That 3 shows up for y when x is 0 on the table, and as we know, x is always 0 at the y-intercept. Now, what about this b value of 2? Where is that incorporated into the table? Well, remember how we said we had slopes when our equations were linear? Where we added or subtracted the same amount to y every time x increased by 1? Well, that was called a common difference. And that was great when we were working with straight lines, but exponential functions are not straight lines. So what relationship is happening here? In each row of our table, x increased by 1. But what about y? How is y changing every time? Well, remember that every time this exponent, or x value, increases by 1, it's really telling us to multiply by this b value another time. So we should be able to multiply the previous y value by 2 to get each additional y value. Does that work here? Yeah, this is right. Multiplying by the b value works. This factor of 2 is called our common ratio. So let's include that in our description for b. Okay, awesome. It's super helpful to know how all of these things are related. This way we can catch a mistake right away if we make one. Anyways, let's use this to help us create this function's graph. Let me move this table over a bit so we have space for the graph. Do you remember what we already know about the graph of this function before we even start plotting these points? We already know the y-intercept from earlier, and that its graph needs to increase due to our growth rate being greater than 1. But now we can use the points from our table to get a pretty accurate graph. Go ahead and pause the video so you can plot these points and connect them to make the graph for this function. Go ahead and check your points with mine. Your graph should go through these points to form a curved exponential function. And do you see that a value on the graph somewhere? Yeah, the a value from the equation is right here on the graph at the y-intercept. And what about the b value? Where can we find that on the graph? It's a little less obvious on the graph, but it's still here. We can see it being multiplied by our y values. Of course, make sure x is increasing by 1 when you're looking for that b value, or you might miss it. All right, now we know how to graph exponential functions and where a and b appear in the equation, table, and graph. Let's take some time to create visual cues in our notes to help us remember the a and b values in these three representations. Mia is giving you some directions on how to do this in your notes template. Pause the video now so you can follow Mia's directions. We'll be moving on to an example problem next, so make sure you're ready to continue. All right, it's time for us to try an example problem. This problem says to graph the function y equals 3 times 1/5 to the power of x. How would you create a graph for this function? What would you do first? Well, we need points to plot on the graph. What's a great way to find some points and keep them organized? Yeah, we'll fill in a table and use that to help us make the graph. Go ahead and calculate the y values for this table, and then create the graph using the points you found. Okay, I'm going to start by calculating this y value. All right, here's the equation. I'll replace x with a -2. The exponent can distribute through to the numerator and denominator. Then we can make the exponent positive by flipping where they're at in the fraction. 5 squared is 25, and 1 squared is just 1. And we really don't need a 1 in the denominator. Okay, so this is 3 times 25, which is 75. So I have the point -2, 75. Continuing to calculate each y value by hand is an option for finding the values we're looking for. And honestly, it's good practice to keep those skills fresh from the previous unit. But in order to be more efficient, I'm going to focus on my a and b values to help me fill in the rest of the table. So I know that the a value is 3, and that should be the y-intercept. And I know that the b value is 1/5. Since each of these x values increases by 1, I can use that ratio of 1/5 to work my way down the table. Since 1/5 represents decay, we should notice our values getting smaller as we go down the table. 75 times 1/5 is 15. 15 times 1/5 is 3. Oh, that's good. Since that's what we already had there, we must be doing this right. Then 3 times 1/5 is 0.6, and 0.6 times 1/5 is 0.12. All right, now what do we need to do? The goal is to graph this function, so let's use the points from our table to do just that. Starting with negative 2, comma 75. Oh, wow, that is not on here. Do I need to scale my axis to get this to fit? Maybe I should just plot the other points and come back to this if I need to. I think the other points might be enough for me to get a general idea of how this graph should look. Let's see here. The point negative 1, comma 15 fits on here just fine. And 0, comma 3 goes right here on the graph. Then there's 1, comma 0.6. This looks pretty good so far. This fourth point should go right about here. And you know what? I think these 4 points are enough for me to be able to graph this function. I'm not going to worry about fitting the point negative 2, comma 75 on here. I could tell what it's supposed to look like without it. I'll go ahead and sketch in the curve going through these points. And here's our final graph. Now we know how to graph an exponential function when given an equation. We use a table to evaluate the function at different x values and use those points to sketch our graph accurately. And we use what we know about the a and b values to check our work. You're likely finishing up your guided notes for this lesson. Remember, as always, to go back to any areas of confusion and get them cleared up before you take on the online practice. See you next time!